Ladies and gentlemen, welcome back again to my channel. In this episode, we're going to demonstrate this FM radio receiver. Very simple design. You saw in the previous episodes, we used the breadboard to build the radio and tested that it works. And then at the moment we proved that it works, everything was fine, we now transfer them to a more permanent board. This is the soldered version of it using VeroBoard. So went from breadboard to VeroBoard. You can use PCB at this point. So let's demonstrate this radio. We're going to use this block here to just make the amplifier a little bit louder, or the speaker a little bit louder. Alright, then we can tune it by just pressing these buttons. Alright, so for copyright reasons, we're gonna shut down the volume right there. Now, the circuit here is very simple. The amplifier here. So let's zoom in a little bit to the amplifier and see. So there's the LM386 amplifier, and we have the output capacitor going into this connector for the speaker. So we can just unplug it back, if you will. And then the input capacitor is this one here. 1 microfarad going to the volume control. We'll tell you why we use this. And then there's this gain capacitor, not required for this system. So when you build yours, don't use this. It is not required. Then we have the antenna there. Sometimes the signal is weak, so we have this female connector here where we can plug in the antenna. So just a piece of wire, about 1 foot, plug it in there. Now, when I was building this, I remembered my friend Itumafo. Back in the days at the university, he likes to build things very compact. So I had him at the back of my mind when I built this. So you can see there are spaces here. There's no reason I didn't use them. But I just thought about him and I was like, okay, you know what, let me just build this like him. So everything was compact. Very, very special friend of mine. He studied a different program, but he was very keen on electronics and he inspired some of the things that we did. Even though he was in our class, learning some of the practicals we're showing during our practical classes, but he was very inspirational to me and I believe to some of my friends as well. Now, so that's why I built this, just thinking about my friend. Anyways, the radio here has so many wires underneath. I don't know if you can see that clearly. Let me see if I can add external lighting. Right, probably helps or it doesn't. So you can see some wires underneath. There are 2 wires right there, underneath the microcontroller and the radio, and also between the radio and the amplifier. There are other green wires underneath. So everything was just compact. Trying to squeeze everything in and not spread everything out. Normally, the normal haircut design will be spread out everywhere, laid out flat. You wouldn't see capacitor jumping, resistor jumping around like this, or this linking wire. Everything would have been flat. But I had to combine some of my skills of keeping things flat with that of my friend Itumafo, using jumper wires and making everything very compact. All right. So that's the radio there. We've built this before. We've shown the first stage, which is the microcontroller, and then the actual RDA5807M. Now we've added the amplifier, and everything is compact with the volume control. We still have these 3 switches here. Again, we're only using the channel functions. We're not using the volume functions of these switches. But you can actually do that if you program the microcontroller to use that. We haven't programmed it to use that. So right here, if I press the channel up, it will change channel going up. Now 2 steps, so let's go 2 steps down. We should get the same channel. Yeah, so back to the same channel. Now if I press the volume, the menu button, and then I press the channel, nothing happens. Doesn't matter how long I hold it. But when I press it one more time, I've toggled it back to channel now. Now we can change the channel. So this works as expected, and there is a 2 seconds delay when I tune a channel. So let me hold it and let it run. So let me add the antenna because this has distortion here. So you would have noticed there was a delay between tuning into one channel and the another, and that delay is about 2 seconds. So it allows you to hear the station and know if it's what you want, and then you can stop tuning. Remember, we have to do this because we don't have a display. If we have a display, we can know exactly when we arrived at the station we're interested in, and then we can stop there. But we don't have a display, so you press it and you hold. You can actually make this that when you long press, it will start tuning automatically, and then give yourself that 2 seconds, 3 seconds window to listen into the station and decide if you want to stop the auto tune. So this is very small radio, like I said. And if you have a big radio set that is like, let me speak directly to my folks, which is a young guy who is going through school, and you need to support yourself through school. And that was me several years ago. And you would stop by the roadside mechanics to learn from them, and do a few of these things. And so if you like my first FM transmitter, it was a guy who was a roadside mechanic. I think he still is. And I stopped by his shop and told him I want to learn how to do this, and then he gave me a circuit diagram that I built. Then since then I've built several other things. Actually, from that same FM transmitter, I was able to build an FM receiver. One transistor FM receiver. Not exactly his circuit, because he gave me a circuit based on A733 or A720. That is a PNP transistor. I'm used to NPN transistors. I was used to, and I'm still used to. And then I decided to convert the circuit to common emitter NPN transistor. So I did a few experiments on my own, and I was able to figure out how to do that. So the FM radio receiver was based on my version of the FM transmitter. But my first foray into this was getting help from that guy. Now, and then also some guys who are like DJs that in my hometown that had businesses of going to play music for people and stuff. Sometimes they have amplifiers that are broken, and they don't have the money to buy new ones. So I would build small not really small. I'll build amplifiers. Output amplifiers, because their preamps and mixers are still okay. I build amplifiers, replace the output of their maybe a Huger or Maxi, whatever amplifier they had. I will replace the output of that with my version of the amplifier, and that works great. So if you are in that category and you have someone who has a very big stereo set, but the radio function is not working, especially FM, and they don't have money to buy new ones, you can build something like this and replace that. You can actually make this and put in your car. If you don't have a stereo in your car, you want to make your own. This is about, I think, about $2 plus, and then this one is like 50 something cents, and there is less than $1. So you're looking at, let's say, $5 components. You can have them together and build a radio for yourself and put in your car. You can use a 3D printer to print the housing or the front. Now that's my volume control. Very low volume, but very loud. So if I go higher, it becomes distorted. That's because I have that gain capacitor. I don't need that. And this sound is actually much loud if I use Now, you see I didn't touch the volume and it's louder. See, what happened is I'm using this. Alright. For copyright reasons, we'll turn that volume off. So let's look at the system and see how we're able to build that. So let's go to the OneNote and look at the circuit diagram. So right there, you see the circuit diagram on OneNote. I'm gonna do something better. Let me explain to you how it works. So it's very busy right there. So why don't I just redraw some portions of this. Let's redraw some portions of this. Now we'll go from explanation, then we can redraw some portions of it. So this is the original radio. We have the microcontroller there, and then we have the RDA5807M, and then we have the amplifier. We used a pre-built amplifier earlier, but now we're using our own version of the amplifier. So we have this LM386 amplifier. There is this capacitor here, the gain capacitor. I said don't use it. It's not required. It just makes it distorted. So you connect that. If you have low volume and you want high gain, connect that and it will increase the gain to, I think, up to 200. So from 20 to 200, you can get from 20 to 200, 20 to 200 the gain. Now again, not required for our circuit, because our radio, the output from the radio is high. The volume coming from the radio is high, so you don't require that much gain. It will distort your speaker. Or you try a bigger speaker and see how it plays out. Bypass pin, we didn't use that at all. And then for pin 2, which is the inverting input, we grounded that and we used the non-inverting input. What that means is, for inverting input, is any signal that comes in. For the non-inverting, sorry, pin 3 that we use, any signal that comes in, so let's just call this pin 3, any signal that comes in goes out and the output amplified, and the amplitude is higher but the phase is the same. When you use pin 2, which is the inverting input, the output is also amplified, but it is shifted by 180 degrees from the input. That's what happens there. So choose whatever you want. We chose 3 and grounded 2. That, of course, pin 4 is the ground and pin 6 is the VCC, or the power supply. And the power supply can go from 4 volts to 12 volts or 5 to 15, depending on the version of this amplifier that you are using. This capacitor here could be around 220 microfarads. It is not critical. We also use 470. So try, look at this spec and see the range and use the right version. Now, the critical, most important one in this design is the input capacitor. Well, maybe not most critical, but it's very critical, it's very important. The reason for that is we discovered that when we build this amplifier, so let me redraw some sections like I said. So imagine this block here is the radio, and this is the output. These are the outputs. So you have the right out and left out. So left, of the speaker. And then let's assume you're using a stereo. In that case, your volume control has to apply to both of them. But in our case, we're using only a mono. So in that case, we have a resistor here. Because practically, that is what a volume control is, variable resistor. Then you have the sweeping arm here that goes into our amplifier. Then the amplifier to the speaker. Simplified version, right? So that goes to our speaker, or if you will, you can just add the capacitor first before the speaker. So that is our speaker. This signal, this almost symbolizes a resistor, this block here, but that's the speaker. Now, when you connect this way, imagine that the receiver, the RDA, is feeling that this load, which is what the resistor is, again, different names for it so you can understand. This receiver is seeing the load connected across its output. So it could attenuate some of the signals coming out from it. And then you have your signal taken from here. So that's practically what you're doing. You are attenuating some of the signals by connecting a resistor from it to ground. The value of the resistor is 10 kilo ohms. Try like 1 meg and see if it makes any difference. But what we found out was that this only works at very low volume. At very low volume. So we wondered why that could be, and we decided to include this capacitor here. So there's a capacitor here, which is, if you remember from our basic electronics tutorials, capacitors are AC closed, but they are DC open. So when a DC signal comes through, the capacitor is an open circuit for practical purposes and blocks the voltage from mixing up. But when AC signal comes, which is what your audio signal is, it allows it to go through. So when we did this, we found out that this volume control works fine. Initially, we thought there was an issue with it, but there was really no issue with it. We just need to put this blocker. Now, one of the advantages, again, remembering the basic electronics tutorials, one of the advantages of this capacitor is to isolate the DC biasing conditions of the radio and the amplifier, and then allow only the AC components to mix up. So that's it. That's the radio. Build it. Now, if you have any questions, any comments, and we'll be able to see how we can help you address it. So this is the third and probably final version of this series. We might come back with maybe a little bit of modifications, but so far this is it. Now I'm going to go back and demo the radio one more time. This is awesome, very simple radio, and we can send you the code if you are interested. So let's go and look at the radio one more time. Right.
I feel nauseous, believe me. Never had a lot of shit come easy. Had to work hard, struggle just to be me. Had to rise up just so they could.
Also, that delay we included allows you to not just flip from channel to channel when, if your hand is there a little bit longer. As long as your hand is not on the switch for more than 2 seconds, you can just release your hand and the station stays where it is. Now, how that works is the microcontroller actually, when you start the delay function on the microcontroller, it stops everything. It stops executing the codes and it stays there. The stack pointer stays on that delay for the time that you have specified. So while it is there, no other function runs. So that's how we are able to achieve this. So you write a delay. If you don't want to stop the execution, you have to use another method, use the millis and start counting from the time you boot up the circuit. The millis will start counting, and then you can assign the millis to a particular value, and then you check the difference between the count, the total count, and the value that you have assigned. And if it reaches predetermined value, then you compare that. So of course, so you have an assigned value and then a difference that you want to, let's say 2 seconds. So you will say, if the millis is up to 2000, which is 2 seconds, then do this. Otherwise, do the other one. Then the functions will keep running. No pausing. It will continue running until, forever. Actually, it will just keep running as long as there's power in it. But when you have a delay, it stops. The stack pointer stays at one spot until that delay is over, and then it continues. All right, thanks for watching again. If you have not subscribed, let me just address this. If you have subscribed, I want to thank you. Thank you so much for coming back and subscribing to my channel, watching the videos, sharing with your friends and all that, coming back again and again and looking at what we're doing. There's another video we released earlier today. It was a premiered video, so we made it earlier on, but we premiered it today. That's on NFC tag. Next week, we're going to release the final version of that, so you can have a complete video series of that NFC tag. So you can tag different NFC cards and have it say what is written on the card. A very interesting video. So watch the last version. After that, we'll probably post the whole codes on our website. That will be that on that. Now, if you have subscribed, so I want to thank you for coming back always. Now, if you have not subscribed, please do us a favor. Go ahead and subscribe. It is totally free, just to help to encourage us to keep doing what we're doing. All right. Thanks for sticking around to the end. If you have not subscribed, please do so right now, and don't forget to like and share this video. Until we come back your way again with more content, stay enthused.